Hello dear students, once more welcome to this YouTube channel. At this point we are going to have a lot of fun with exercises on rectangular form of complex numbers. So to start, we are going to look at simplification of some expressions using basic operations of complex numbers, and we are going to look at a complex equation. Let's start with the first part. How can we simplify some expressions using basic operations of complex numbers? We are going to do this with the help of this exercise. So consider z1 equals to 6 minus 3i and z2 equals to 9 plus 7i. The first part will consist of simplifying the expression z1 plus z2 bar. Z2 bar represents the complex conjugate. Do you remember from our previous video? So we're going to have the complex conjugate of z2 bar, or of z2 rather. So remember that the complex conjugate is that number obtained by changing the sign of the imaginary part. So our z2 is indeed 9 plus 7i, so its complex conjugate will be 9 minus 7i. Therefore, to simplify the expression z1 plus z2 bar, we are going to have 6 minus 3i plus 9 minus 7i. Remember how we add up complex numbers? We collect the real parts, we add 6 plus 7 plus, remember, we have minus 3i minus 7i. Okay, so we're going to have 6 plus 9, which is indeed 15, and we're going to have minus 3i minus 7i is indeed minus 10i. And that is what we have for the first part A. Now we want to compute z1 all squared. So z1, remember, all squared is equals to 6 minus 3i all squared. So this is equals to 6 minus 3i times 6 minus 3i. So this gives us, remember how we multiply this 6 times the 6 here, which gives us 36. Then we multiply 6 times 3i, which gives us minus 18i. Okay, then we multiply minus 3i times 6, which gives us a minus 18i again, and then we multiply minus 3i times minus 3i, which gives us plus 9i squared. What do we obtain? We're going to have 36 minus 18i gives us minus 36i. Remember, I squared is minus 1, right? So we're going to have minus 9 here. So we're going to have 36 minus 9, which gives us what? 27 minus 36i. Okay, now let's compute the other part, which gives us z1 bar, which is indeed, remember, we have to obtain the complex conjugate of z1. So we're going to have the complex conjugate of z1 is indeed 6 plus 3i divided by z2, which is 9 plus 7i. Do you still remember how to perform division of complex numbers? We multiply top and bottom by the complex conjugate of the denominator. So we're going to have 6i times 6 plus 3i times 9 minus 7i divided by 9 plus 7i times 9 minus 7i. So what does this give us? Remember how to multiply. We're going to have 54 minus 42i plus 27i minus 21i squared. Okay, I squared here, divided by, we're going to have 81 minus 63i plus 63i minus 49i squared. Okay, after simplification, we're going to obtain 75 minus 15i divided by 130. If you simplify this further, we're going to have 15 over 26, okay, minus 3 over 26i. And that is how we can play with complex numbers based on the rectangular form of a complex numbers. Okay, so let's look at few more exercises. This is a basic simplifications. So remember here, we just want to simplify these very simple complex expressions. So remember here that if you want to simplify I cube, we can rewrite it. The law of indices allows us to rewrite it as I squared times I. Okay, so we're going to have, remember, I squared is what? I squared is minus 1. So we're going to have minus 1 times I, and the answer here is minus I. So for I to the power 16, remember the law of indices allows us to write it as I squared all to the power 8. Remember, I squared is minus 1, so we're going to have minus 1 to the power 8. Therefore, the answer here is 1. For this expression 1 over I, we can just simply multiply top and bottom by I. Okay, we're going to have times I times I. So we're going to have I over I squared, which is equals to I divided by minus 1, and the answer is minus I. As simple as that. Now, let's look at a simple complex equation. This is still part of our fun, right? Our fun time. We're going to solve for x in the expression I times x minus 3i bar equals to 4 times bracket 2i minus y. Remember, we first simplify the expression on the left hand side. The solution here indeed consists of simplifying the expression and comparing both equations. Okay, remember, I times x minus 3i bar is equals to I times x plus 3i, and this is equals to I times x plus 3i squared. Remember, I squared is equals to minus 1, so we're going to have I x minus 3, and the expression 4 times 2i minus y is the same as 8i minus 4y. So this implies that our I times x minus 3 is equals to 8i minus 4y. So we compare. What we do with this complex equation, to solve for the unknowns, we compare the real parts and the imaginary part. We first begin by comparing real parts. The real part of the left hand side and the real part of the right hand side. Remember, the real part is that part without the I attached to it. So we're going to have minus 3 equals to minus 4y. Therefore, our y is equals to 3 over 4. So if we now compare the imaginary parts, remember, the imaginary part is that part with the I, or is a coefficient of I in each of these expressions. So we compare the imaginary part of the left hand side to the imaginary part of the right hand side. So we're going to have x equals to 8, and that is how we can play around with some expressions with regards to complex numbers. So what did we go through during this short time we spent together? We've actually simplified some complex expressions using basic operations like addition, multiplication, division, and we've actually looked at complex equation, how to simplify and compare the real part and the imaginary part to solve for the unknown. I really hope you had fun during this time we spent together. Thank you for listening up to the end of this video. See you in the next video. Feel free to subscribe if you found this content very interesting. Feel free to comment so that we can improve in our next coming video. Why not share also this YouTube video? Thank you so much. Bye.